This video examines the function blocks required to implement the hot air temperature loop for the hot air furnace. These will be presented by constructing the block diagram. A good starting point is the hot air temperature transmitter. As on the P&I diagram, we will represent this component by TT enclosed in a circle. In process applications, the future is inputs in the form of digital values from smart transmitters. However, 40 to 20 milliamp inputs remain common, and other types are also encountered. Digital controls begin by converting each input to engineering units. To perform this conversion, a PV block must be configured for each input. The PV block in the diagram is for the hot air temperature. The input is the signal from the transmitter. The output is the temperature in degrees Celsius. Open the configuration window for the PV block. For a commercial control system, the PV block requires configuration parameters to properly convert the input from the transmitter to degrees Celsius. But for the simulator, all inputs from the model are in engineering units. No conversion is required. Only the input must be designated. The drop-down list for measured input contains all of the inputs from the process model, one of these being the hot air temperature. Most PV blocks require parameters such as an identifier or tag name, a description, the measurement range, a filter time constant, etc. Close the PV configuration window and the point window. The PID block in the diagram is for the hot air temperature controller. The PID block has two inputs, the process variable and the set point. The PV input is the output of the PV block for the hot air temperature. The set point is provided by the process operator, so no source is indicated for the SP input on the block diagram. The control variable is that process variable whose value is to be maintained at or near the value of the set point. Some use C to designate the control variable. However, PV will be used herein. In order to maintain the control variable at or near its set point, some variable must be at the discretion of the controller. For the hot air furnace, this is the fuel valve opening. Control engineers consider this to be the manipulated variable, hence the designation M used herein for the controller output. The PID block will be examined in detail in subsequent videos, so its configuration window will not be presented at this time. The valve block in the diagram is for the fuel valve. In most commercial control systems, the valve block, or its equivalent by another name, can be configured for any type of final control element. However, most implementations present a feature that is specific to a valve, or more specifically, to a valve equipped with a pneumatic diaphragm actuator. Because of their behavior on failure, such valves are very popular in the process industries. On loss of control signal or loss of power, that is supply air, the pneumatic diaphragm actuator can be configured to fail either fully closed are fully open. For loss of power to an electric actuator, a cost-effective approach to provide such behavior continues to be elusive. Consider a valve that fails closed. On a zero value for the output signal from the valve block, the valve must be 0% open. As the output signal increases, the valve opening increases. Hence, this behavior is increase. Now consider a valve that fails open. On a zero value for the output signal, the valve must be 0% closed or 100% open. As the output signal increases, the valve opening decreases. Hence, this behavior is increase-decrease. Including this configuration parameter in the valve block provides a major benefit. The input to the valve block can always be % open, regardless of the failure behavior of the valve. The valve block converts the input in % open to whatever signal is required by the final control element. Click the symbol for the fuel gas valve to open the point window for the valve block configured for the fuel gas valve. Expand the parameters menu and select point configuration to open the configuration window for the valve block. The output of the hot air temperature controller, tchotair.mn, is configured for the input to the valve block. The units are % open, regardless of the behavior of the final control element. In simple feedback loops, this is beneficial but not essential. In more complex control configurations, this is a major benefit. The entry for output direction depends on the failure behavior of the valve. There are two options, increase-increase and increase-decrease. The fuel gas valve fails closed, so the appropriate choice for output direction is increase-increase. With digital communications and smart valves, the process controls can transmit the % open value from the controller directly to a smart valve, whose configuration provides the output direction feature or its equivalent. Smart valves will eventually displace conventional valves, but this will take some time. In the meantime, valve blocks will provide the output direction feature. The next video examines the PID block in detail.